For us, you do not lose any visibility. Using our DMP, you will still see all the performance statistics from the fiber and from the physical disk that you need. So when there's a performance problem in your environment, you can easily do troubleshooting with our tool. In fact, with VORM, you can do troubleshooting. You know exactly where are the hotspots, and you know exactly which volume to move out of the hotspot to improve performance in your environment. So these are the things that we help. So this is acquisition cost. The second one is deployment. So once you have a new array, you want to quickly use it. Right? You want to prove that your purchase is for a purpose, is a purposeful purchase. So in terms of deploying the array, other than the ability to move volumes to the new array, we also provide storage templates. For new volumes that you need to create, you can use this template to very quickly provision the right storage tiers you want accordingly for your application's requirement. Thirdly, optimize storage. Once your storage is deployed, is running, you need to optimize storage. Like I mentioned before, you need to be able to expand and shrink on the fly depending on the need. That's optimizing storage, increasing utilization level. We also have technology like compression and deduplication that I mentioned this morning that can help you reduce your need for more capacity, especially in backup environment. Right? You can use either our net backup deduplication or you can use our file system deduplication. That will help you minimize the amount of duplicated blocks in your environment, especially in virtual environment. So that will again, within your storage management lifecycle, a very important part of helping you save costs. The next one will be get thin and stay thin. Now if you use thin capable storage, we in Storage Foundation has got the API that can help you do storage reclamation on the fly so that your thin volume stays thin. A lot of users, when they use thin capable storage, they start by having a very small volume, but very soon the volume will expand to a volume as large as non-thin arrays because they do not have a capability to maintain the optimization in a thin storage. Because a lot of arrays doesn't have the intelligence of whether the file is in use or not in use. Arrays only can see ones and zeros on a disk. As long as the block is not all zeros, the array will assume that this block is in use. But we know that deleted files are never all zero out. Right? Deleted files are just an update on the file system. The block that has the delete files still has ones and zeros. Arrays will think that there is a valid block, and you will continue to use and hog that block. So your thin array becomes fat over time. We have the API because we own the file system. As long as you're running Veritas file system, we know exactly which file is a valid file, which file is a deleted file. So we can integrate with the API to compress and move out all the deleted files and blocks so that your thin array stays thin and you get the maximum ROI from your thin capable array. Right? If you don't use a thin capable array, then this is not applicable to you. But if you do, then remember that we have the capability to help you save more costs. And then at the end, online storage migration. So I mentioned before, we can move volumes on the fly between arrays for you. So throughout the entire life cycle, we can help you maintain and maximize your ROI for your storage. And all this is managed from one platform, which is Veritas Operation Manager, we call VORM. So VORM helps you centralize visibility and reporting. So across all your servers, you can see the utilization level. I'll show you some screenshot later. This is where we deep dive into some of the feature. You can also control all the application availability, right? Your clusters, which cluster node is it running on? Do you want to fail over? Do you want to reconfigure your cluster? Do you want to DR your cluster? Everything is from this same console. And you can get automation, day-to-day daily tasks, expanding volumes, shrinking volumes, creating a new mirror, creating a new snapshot, doing reporting, doing metering, doing chargeback, everything from the same console. Everything is automatically discovered. If you use Storage Foundation or VCS, Veritas Cluster Server, VOM is free. Because it's a management console for Storage Foundation, it's free, as long as you're a Storage Foundation user. If you want to manage a server that is not running Storage Foundation or Cluster Server, all you have to do is put in an agent. And that server can be part of one of the servers that is being reported by VOM. Right? If you have a virtual server which is not here, if you have a VMware server, we can auto-discover the VMware server for you. Because we work closely with VMware, we have the VMware ESX API that we use to query the ESX server, so that you know all the VM in the ESX server. You also know all the volume and all the volume capacity utilization within the VMware server. Although you do not install an agent or you do not install Storage Foundation into the ESX server, we can still discover all those for you. So whether it's physical or virtual, one platform, you can manage that. This is what I mean by application to Spindle in the previous session, if you were in the session. So from the OS or the app, right, Storage Foundation covers up to this layer, right? And then this is the hardware array and downwards, right? So with VOM, you can get up to this layer of visibility. If you add VOM Advanced, which is an option within VOM, that you have to pay for it, VOM will then come with the list of APIs for all the major array vendors, the disk array vendors, and you can discover the layer below. So with that, the database instance, we can relate the database instance to the files underneath it, the files to the file system it lives on, and the file system that lives on the volume, and the volume that corresponds to the LAN on the array, and within that LAN, where are the physical disks, whether the LAN has a snapshot or whether the LAN has a replica, everything is discovered from application to hard disk to Spindle on one console. So this is what I mean. If you have a team of DBAs and system engineers and storage engineers or storage admin working together, they will not talk the same language. Database administrator will talk about tables and space and files. OS administrator will talk about file system and volumes. And storage admin will talk about LANs and replicas and physical disks and enclosures and so on. So this screen will be the screen that all three can then talk the same language, which is a great help to a lot of project managers. So this is some of the screenshots that I've selected for this session. So from one console, you can see that you have the whole list of all your databases in your data center, automatically discovered if they are running Storage Foundation. So in this case, 8 Oracle server, 0 DB2 server, 24 MS SQL server. And some are online, some are offline. All your application in your data center, all your operating systems in your data center, number of account, number of faulted, number at risk, number of healthy. Right? Anything that's blue, you can click and drill in. On this table here, all your arrays. So in here, this data center has got EMC array, has got Hitachi array, has got NetApp array, and so on. So you can also see all these things, and when you click onto this, for example, you can drill into the EMC array and see what's inside there. Everything from the same platform. Right? And then all your clusters. We have many different forms of cluster. I won't go into detail for this session. But other than normal VCS cluster, we have cluster for Oracle RAC, we have cluster for Sybase CPE, we also have high-end clusters like CFS and so on. Okay, once you click into any of this, for example, I click into host summary. I can see a whole list of hosts here, the operating system type, the host name, IP address, and most importantly, I can see file system utilization for that server. And it will sort for you highest utilized to the least utilized. So exactly you can see like the red ones are server that has got more than 80% capacity. That means these are server that is actually at risk. They are going to run out of this space and they are going to crash. And at the bottom, which is not shown here, the green ones are the ones that maybe they have over provisioned storage. They have very low utilization, and those are the servers that you may want to take storage back and give it to the ones that is in red. So you do some optimization from there.